So today we're going to look at angles that are formed by parallel lines when a third line intersects the parallel line. So look at this diagram right here. I have line A and line B, and notice these two little arrows in the middle of the line. When that happens, we know they are trying to tell us that lines A and B are parallel. And parallel lines never intersect, right? They go on and on forever and they never touch. And again, these little arrows in the middle of the line is what tells us that they are parallel. And then line C is drawn here in the middle of the diagram and it goes through the lines and it is called the transversal. Transverse means to go across. So this line, line C, goes across line A and line B. Okay, so what happens is we now form 8 angles. Look at the angles we have. Angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7, angle 8. Okay, can you look at this diagram and name 4 pairs of vertical angles? So what's one pair of vertical angles? Remember, vertical angles are formed by intersecting lines and they're across from each other. So angle 1 and 3 are vertical, right? So angle 1 and angle 3. Can you name another pair? I see angle 2 and angle 4. I see angles 5 and 7. They're across from each other. They are vertical angles. And that leaves the fourth pair of angle 6 and angle 8. Okay? Now, 1 and 5 are congruent. How could we show this? So here's angle 1 right here, and here's angle 5. Well, think about what we did with patty paper. If we traced angle 1 on patty paper and we slid it down, it would match exactly over angle 5. So which transformation is a slide? We would translate it, right? I could trace angle 1 and I could slide it down and it would match angle 5. That would be one way to show that they are congruent. So we could show it by a translation. Okay, now angle 1 and angle 5 have a special name. They are called corresponding angles. Corresponding angles. And they're called corresponding because they're in the same spot. Angle 1 is in the upper left of this diagram. Angle 5 is in the upper left of the bottom angles, right? Upper left, upper left. So there are 3 other pairs of angles that are also corresponding. Angle 2 and angle 6 are both in the upper right. So angle 2 and angle 6 are corresponding. Can you name another? Angle 3 is in the lower right. Angle 7 is in the lower right. So angle 3 and angle 7. And then the last pair, which one am I missing? Angle 4 and angle 8. The angles that are in the same spot are called corresponding angles. Okay, so we've talked about vertical angles, which we already knew. Remember, vertical angles are the ones with intersecting lines that are across from each other. And we've talked about corresponding angles. Corresponding angles are sort of in the same spot. So 1 and 5, 3 and 7, those are corresponding. Now let's look at another pair of angles. Let's look at angle 3 and angle 5. Angle 3 and angle 5. Okay, so look at angle 3 and angle 5. If I look at the two lines, they're between the two lines, right? They're on the inside of the diagram. So we call that the interior. Okay, so 3 and 5 are interior angles because they're between the two lines. They're on the inside. And then the next thing we want to know is that 3 is on the right side of the transversal and 5 is on the left side of the transversal. They skip sides, right? That's called alternating sides. They alternate. One's on the left, one's on the right. So they are alternating, One's on one side of the transversal, one's on the other, and they're on the interior, the inside of the diagram. So we call angle 3 and angle 5 alternate interior angles. Alternate interior angles. Okay, inside of the diagram, alternate sides of the transversal. So alternate interior. Notice they make a Z. You see that Z sort of? Okay. So do you see another pair of alternate interior angles? Well, what else is on the inside of the diagram and different sides of the transversal? Do you see angle 4 and angle 6? Okay, see how that sort of makes a funky looking Z there? So angle 4 and angle 6 are also alternate interior angles. Now, we could get patty paper and we could trace angle 3 and we could rotate it around and it would match with angle 5 because the lines are parallel. We could do the same thing with 4 and 6. We could trace angle 4, we could rotate it around and it would match with angle 6. So when lines are parallel, alternate interior angles are congruent. They have the same measure. Okay, so vertical angles, that's like angles 1 and 3. Corresponding angles, that's like angles 2 and 6. And alternate interior angles are our third type of angle. Well, now let's look at a fourth type. One more type today. So let's look at angle 1. That's right here. Whoops, that's a bad tracing, isn't it? Angle 1 and angle 7. Okay, now are they on the inside of the diagram? No, they're on the outside, right? They're called exterior angles because they're on the outside of the diagram. Are they on the same side of the transversal or alternate sides of the transversal? They're on alternate, right? One's on the left, one's on the right. So these are alternate sides of the transversal. They're on the exterior of the diagram. They are called alternate exterior angles. Alternate exterior angles. All right, can you find another pair of alternate exterior angles? There's another pair, right? Angle 2 right here, and then way down on the other side, angle 8. So angle 2 and angle 8 are alternate exterior angles. So if we were to take patty paper and trace angle 1, we could rotate it around and put it on 7 and it would match. We could do the same thing with 2 and 8. We could trace 2, we could rotate it around, it would match angle 8. So when lines are parallel, alternate exterior angles are also congruent. They have the same measure. So let's use what we know. Let's identify the types of angles. Let's say their relationship, and then let's find the angle we don't know. Okay, so look at this one. I have angle 1 and angle 2. So look at angle 1 and angle 2, see if you can figure out what they are. They're on the exterior of the diagram, right? They're not between the two lines, and one's on the left and one's on the right. So these are alternate exterior angles, right? Alternate exterior, and I abbreviated a little bit. Now, what do we know about them? Alternate exterior angles are congruent. They have the same measure. So if angle 1 is 65 degrees, what is the measure of angle 2? If we put that little M in front of the angle symbol, that means the measure of angle 2. Well, if 1 is 65 and they're congruent, angle 2 is 65 degrees, correct? Okay, let's look at the next one. What about angle 5 and angle 6? Well, they're in between the two lines, so they are interior angles, and one's on the left and one's on the right, so they alternate around the transversal. So these are called alternate interior angles. Alternate interior angles. And when alternate interior angles are formed by parallel lines, they are congruent, right? And congruent means the same measure. So if angle 5 is 120 degrees, what is the measure of angle 6? 120 degrees. They have to be congruent. Okay? Next one. Angle 1 and angle 2 again, but this time they're down here. So look at angle 1, look at angle 2. What kind of angles would you call those? They're formed by intersecting lines. They're across from each other. They are vertical. What do we know about vertical angles? Vertical angles are congruent. They have the same measure. Okay, so if angle 2 is 70 degrees, what is the measure of angle 1? 70 degrees, right? Okay, y'all are good at this. Okay, so let's look at the next one. Angle 7 and angle 8. What would you say about angle 7 and 8? Well, they form a straight line, right? They form a straight line. So they have to do what? They have to add up to 180. So they are supplementary. This is a word from our previous lesson, right? Supplementary. That's a big word. And we just said that if they're supplementary and they make a straight line, they have to add to 180 degrees. So if angle 7 is 80 degrees, how do I find angle 8? I would do 180 minus 80 degrees, and what would I get? The measure of angle 8 would be 100 degrees. All right, one more. What about 7 and 8? 7 and 8. So I see 7 here and 8 here. Okay, so look at that. I have one, if I look up here, this one's in the lower left. 8's in the lower left. They're in the same spot, right? Lower left, lower left. So these are corresponding angles. I'm going to abbreviate that. They're corresponding. When the lines are parallel, corresponding angles are congruent. That means the same measure. So if angle 8 is 130 degrees, what is angle 7? Well, if it's congruent, it has the same measure. Okay? All right. So now you know the different types of angles you need to identify, and you know how to find the ones you're missing.